Consider a classical model of electron such that a nucleus of charge plus E is uniformly distributed within a sphere of radius 2 angstrom. Fine. So we have a sphere of radius 2 angstrom. And the entire charge in this sphere is plus E. An electron of charge minus E at a radial distance 1 angstrom moves inside this sphere. Here it is moving electron. Find the force attracting the electron to the center of the sphere. Calculate the frequency with which the electron would oscillate about the center of sphere if released from rest at this radial distance. So first let's find out the force. So we know that if we find the electric field at some distance x, the formula is F is equals to kqx by r cube, where this is the electric field. So force will be charge times electric field. The charge currently we have is electron, which is experiencing the electric field at a distance x. That electric field is given by this formula. We do not use a negative sign when finding force. So we just write E, and the x distance is given to us as distance 1 angstrom. We'll write that later, upon r cube. That is the force. Now this is the force which can also be written as ke square by x r cube as the centripetal force. This electrostatic force is only providing the centripetal force, mv square by x. And what we have to find out? We have to find out the time force acting on electron. Calculate a frequency with which the electron will oscillate, and find the force attracting the electron to the center of the sphere. So this is the answer to that question. I will find out omega later, but first find this value of this expression ke square, and x is given as r only, r by 2, because they are giving us a distance of 1 angstrom and the entire radius is 2, and this is r cube. So you can cancel 1 r, ke square, 1 r can be cancelled, so we have 2 r square. That is the force expression, and let us find the value of it. 9 10 power 9. It is a proton, electron same charge, 10 power minus 19 whole square, divided by 2 into radius is 2 angstrom, that is 4 10 power minus 20. So we get 2.56 into 9 is 23.04. 23.04 divided by 8 into 10 power 9 minus 38 plus 20. So we get 2.9 approximately, 10 power minus 9 Newton. That is the expression for force acting on this electron revolving in the sphere. Now we have to find out the frequency with which the electron would oscillate about the center. For that we have to find out the acceleration. Okay. So for acceleration we can find out r omega square. Instead of writing mv square by x, we can also write r omega square or x omega square. So this we have calculated entire force, which is 2.9 10 power minus 9, 2.9 10 power minus 9 divided by 1 angstrom, which is x, 10 power minus 10, and then we'll get the omega square. So we'll get omega square as 29. So omega will be root 29, and we have got the frequency, that is 2 pi by omega if you want to find in hertz, root 29, and that is the answer to the question. इसमें एक चीज़ ऐड कर लीजिए, I have forgotten to divide by mass. Okay, though I have taken force and I simply wrote it equal to acceleration. This was force, so mass I have to also divide it with, then I'll get the correct answer. I forgot to divide by mass. You can see I've equated force with just r omega square or x omega square. I did not take mass, so kindly take mass here and then you'll get the correct answer. So mass of mass of electron, which is actually revolving, is 9.31 10 power minus 31, then you'll get the correct answer. So that is also comes under root. So 2 pi by root 29 into root of 9.1 10 power minus 31. Then you'll get the correct answer.